Hello, ladies and gentlemen. Welcome back to the SAPI IP Business Talks. Today, you see that on the title, we talk about designing around and avoiding patent infringement. So it's about product development and the question, how do we integrate our understanding of patents? And if necessary, how can we bypass patents which block or we would potentially infringe. That's our topic today. We have two accredited guests who are on LinkedIn with us, and they will also be for you there. It's Islam Eldeg. Islam is heading the innovation department at the King Fahd University of Petroleum and Minerals, and he is keen on technology transfer, so he tries to bridge the gaps between academia and industry. And also we have Nicos Raftis with us today, and he is with patent information, ideation, prior art searching, especially with AI tools and a whole toolbox he is working with and offering. That's the two guys which are in the background, our ambassadors. Our guest today here live in the studio is Nicos Raftis. And Nicos, hi, good to have you here. Nicos is founder and director of IP research and paradigm shift. He takes care about these very specific issue of bypassing a third-party patents, especially when it comes to potential infringements, and or even when it is infringed. Okay, so and that is a very delicate and specific capacity and competency which he has. He's located in Cyprus, so we are in Cyprus today. And yeah, thank you very much for taking the time. And to your audience, please make sure that when you have questions or comments, write it in the chat. I'm happy to pick it up and to present that also to Nicos. We can discuss about that. Nicos, thank you very much for taking the time. And my first question is always, how did you came into that strange field of IP?
Sure. First of all, thank you for this opportunity, Alex. Well, my background is in manufacturing engineering. I did manufacturing at Cambridge, and I spent most of my career developing new products until at some point I decided to go back for a PhD on enhancing creativity in new product development. So creativity in new product development essentially is all about working with product development teams to help them to push towards breakthrough ideas as opposed to incremental improvement. And there are two main elements to that. The first is about cultivating thinking skills. The second is how you make the most out of existing knowledge. And a vast repository of knowledge is patents. So early on, I explored how you can use patents to help you move towards new ideas as opposed to keeping you within your comfort zone. And of course, critically in new product development is also that while you're developing and you're trying to produce new ideas, etc., you make sure that you maintain freedom to operate. It doesn't always work nicely, so you have troubles sometimes. But essentially, I got into this field because of the importance of leveraging the knowledge of patents in order to push forward towards breakthrough ideas to enhance creativity in a product development team. Yeah,
that sounds good. Okay. So I'm in that field for more than 20 years, and I started in Germany at the Fraunhofer Gesellschaft. So and we made state of the art retrieval, and I learned this patent information game, and always. So even 20 years ago, people said patent literature is a unique source of information. And I mean, that was the time where it was really tricky to get that kind of data. So you needed very specific databases, and you needed skills to get access to these databases via a telnet, a specific service on the internet. So the internet was something strange,
Yeah.
but basically nothing changed. Okay, and what did not change is that people don't like to read patents, and that they don't understand patents, and that because patents are, I mean, from the public side, yeah, from the government, it is said that patents are a wonderful information, a source of information, and you should use it for product development, for whatever.
Yeah.
But the truth is that many people have real issues to understand
Correct.
patents when they read it. So what are you doing to help people with this, let's say, basic problem?
All right. I think perhaps it's important to explore a little bit what we mean by understanding a patent.
Okay,
Of course, there
fair enough.
is the first barrier, which is the language that a patent document is typically written, which is a kind
Yes.
of legalistic language, etc., with the formalities that it has. But beyond that, there are different levels of understanding that are needed. So if you look at the fundamental objective of a patent, a good patent is there to protect an advantage, a competitive advantage that somebody is seeking over competition, with regards to the way of implementing a function or the way of solving a problem. And this can relate to a specific implementation through a given conceptual direction of a given function, or in the way that you are achieving some attributes to the product. The problem with many patents, even for patent professionals, is the fact that you frequently come across patents, you read a claim, and it shows some structure of a technology, etc. And then you go, okay, so what? How does this relate to the advantage that you're seeking to protect?
Okay.
And
Okay.
so that's where a good understanding from an engineering point of view, together with a good experience from the patent system, needs to blend. Because you see a given structure that is being claimed, and then you need to figure out how that relates to the function of a product or to the end result that needs to be achieved, the solution of a problem. Sometimes you need to understand how that relates to fundamental governing physics. Sometimes you need to understand how that relates to a sequence of operation in a mechanism, etc. And frequently, without a good understanding from an engineering point of view, it becomes difficult. So sometimes, before you go into exploring patents in a particular technology, before you do that, you may need to explore the basic governing physics of a technological system. So you are up to a good level of familiarity of how things are supposed to work, and then go and read the patents.
Excuse me, Nicos. I had a discussion with a chemist, okay, Dr. Betterman, and she told me that there are translation processes, okay, in chemistry, so that you have a molecule and process, and then you translate it into the language of a patent. And after that, when you try to understand what is patented, you have the next translation again back into the chemical language, so to speak. And what you tell me now is that this exactly the same is also in mechanics, for example.
Yes.
That there are these translation processes into the patent language in terms of making sure that the claims are clear and that you show a certain technical learning and all these aspects of the patents. But on the other hand, when you really want to understand how this mechanical thing works, you need a translation, and this is what you say, right?
Yes, exactly. I mean, let's say that you read a patent specification, and in the preamp, the background to the invention talks about, let's say, the need to reduce manufacturing cost, and it says, "Oh, this patent it helps in reducing costs, etc." And vague description of the objective like that, and then you see that structure, and it's okay. So how would this contribute to a reduced product cost? And it's that link that you need to make. Or you see, for example, an impeller, and the objective is to make that impeller being more silent, and it describes a particular geometry. Unless you are able to understand the features of that geometry potentially in terms of governing physics, how they could relate to the mechanism of generating noise, you cannot understand the patent.
Yeah, got you. Now, you understand maybe the patent itself, so to speak, the claim, but the impact which this claim has, this is not clear, right?
Exactly, and the level of understanding that is required is different depending on the objective that you're having. So if, for example, you're carrying out a patentability assessment, you may not need to go to that level of understanding of being able to make that link between the elements of the claim and the actual governing physics and why that is delivering the advantage that is seeking to deliver. But if, for example, your objective is to assess a competitor's portfolio to figure out what actually they're trying to achieve here, or even more demanding, your objective is to work around a patent that is posing an infringement risk for you, without that depth of understanding, you cannot do anything. So there are different levels of understanding, and of course, different levels of effort that you need to devote to build that understanding, depending on what you're trying to achieve.
Okay, that makes for me totally sense. I got you. That means we have different kinds of information which lies in that patent document, and depending on what you want to achieve, depending on your problem, depending on the solution you're looking for, depending on the issue which you have, you need to interpret that in different ways, and that is what you say, that understanding we have to be very careful with that term, because according different people, different objectives, a different understanding is necessary. So, and what you're doing is you help with this kind of translation. Is that correct?
Correct. I mean, for example, we frequently work with patent attorneys that are in litigation process. And if there is a complex patent there, let's say a complex mechanism, etc., we may even need to devote the effort of taking that all that information from the specification, from the figures, from the claims, translating it into a 3D model in CAD, and then even doing some animations in order to ensure that there is clarity about what that thing actually is, how the claims come about, and how these relate to the objective, because it is absolutely critical if you are at litigation. In a similar way, if you're trying to work around, that's absolutely critical. But if, for example, you're just doing a first assessment of potential identification of infringement, it may not be critical. Or if you're doing a first assessment of patentability, it may not be critical. So you need to determine the depth of understanding with the demand of the task that you have at hand.
Okay. I mean, that is something which I really understand. I think when you said first we have a three-dimensional issue, okay, maybe even with fluids or whatever. I mean, that is really nasty to get this understanding, right? Yeah. And then you say you have also dynamic aspects of it. I mean, what we have in a patent are these figures, and these figures are not just two-dimensional. They are not dynamic, not colored, not anyhow really helpful, to be honest, to understand it. Really.
And cluttered, and frequently a lot of unnecessary information there that can cause confusion.
Yes. Okay. That's the point. This means when it becomes really complex, and you you really need the nitty-gritty detail to understand. So where does the fluid goes in, and at the same time, as an example, at the same time we have something is opening, something other is due to dynamic closing, and this happens all at the same time. So then it becomes really tricky compared to the claims. What is now really infringing and what not, and how can we bypass that, right?
Plus, sometimes, especially in claim language, there could be definitions of certain objects that the writer creates, and then you're wondering, what is this thing and what is that thing, and unless you actually see it, it can be very, very difficult.
So I would say it would be absolutely brilliant when we have something on the Dplex about that we can show that, and also when later on when you have in the chat on LinkedIn maybe some examples also to show that. We have it not right now here in the show, but also in the show notes and in the discussion, you should give the people an idea what that means. But I got you. So Islam has a good question, because he comes from the technology transfer perspective on the whole thing, and he says that might it make sense? So you are obviously focused pretty much on these infringement situation, okay? Which obviously, but I would say an infringement is also a technology transfer discussion, because at the end, whether you bypass it or you need a different solution, whatever happens, it is also correlated with technology transfer and understanding technologies, and understanding especially the needs and the possibilities to bring them together. So what Islam says, and that is a fascinating aspect, is could this kind of understanding, this level of understanding, you said cost reduction, easier to produce, whatever, could that help also in tech transfer?
I actually, that is an excellent point, because if you take it from the infringement point of view, when you're trying to license a technology, essentially a licensee needs to ensure, first of all, that your technology is not going to get them in trouble in terms of infringement of somebody else's patent. But I'll put that to the side for now, and I will go to the other thing. Somebody that comes to buy that asset, that technology through a license, they need to make sure that that patent that you are having is very strong, in the sense that it's not easy for other people to go around it. And I often say to my clients the following: if anybody is to be able to go around this patent, it better be you. So you first try to go around a patent application that you're having before you even file it. And any loopholes that you identify, close them before the file. So actually, because...
Isn't that a big challenge? Isn't that really difficult for an inventor to because inventors think that this is not just the best solution.
Absolutely, they're so attached to their idea. Yes, exactly, and that is frequently the problem also. Even in large companies, when they are faced with an infringement issue, and then you try to generate alternatives in terms of changing the design, etc., they have difficulty because they are marked to their solution. They're so attached to their own solution. It's their baby. It's in their mind the absolute best thing that anybody can produce. So nothing else can come close to it in terms of performance, or so anything else would be, and that's the mindset that creates a substantial difficulty.
Absolutely, that is one aspect. So that's the own mind baby. But it's also what I have experienced with companies is that you have a path dependency. Okay, so they come up with this solution because of their production background, because of typical materials, because
it's what we refer to as psychological inertia as well. You have a set number of things that are said. You have a familiarity in terms of existing knowledge. is pushing you down a given route.
Yes. So, which means when it comes to patents, so what I try always to explain is patents do not reflect the reality. This is simply not true, which means your reality is your material, your solution, your production background, your manufacturing experience, whatever.
Yeah.
It's fine. But the patent does not has to reflect that. So try to think out of the box, and this is exactly what you are doing on a methodological way and on a with tools that you help these people to think the same problem in different ways. Yes,
correct. And also from a licensing perspective, technology transfer perspective, we may also, this exercise may, and the understanding of that patent may also highlight the need to go beyond a single patent application. It may highlight the need to strategically build a portfolio.
So now, when we think in a process, in a product development process, right? So does it make a difference when you? I mean, in very early phases, we have high flexibility how we want to do the things, right? But in later stages, and I would say, let's say you are when you have an industrial product and you are close to the start of production, so the manufacturing equipment is already there, and when the companies face then a potential infringement, so does that makes a difference, and how can you help there?
Yeah, it makes a huge difference. And in fact, if you look at the options that somebody has when discovering that there is an infringement risk, very, very quickly, you have three options. Either you try to buy a license if it is possible from your competitor, or you try to invalidate that competitor's patent if that may be possible, or you try to change something in your design to avoid the potential infringement. Now, any design change has a cost, and the later that you are in the development process, the greater the cost. And what is that cost? Essentially, there is the cost of the engineering design change that may relate to the effort that you need to have in redesigning, in testing, proving, changing tooling, if you already tooling is in place, etc., all of those stuff. But also the cost in relation to delays in getting to market. Okay, so that's the cost of change. And then, so the challenge is to minimize this cost of engineering change. If you need to change something in your design to avoid infringement, minimize that change without negatively impacting product performance and product cost.
That means what you're saying.
So that's not easy.
Yeah. No, I get you. I mean, that is a very practical issue, right? So you're saying it is not just bypassing a patent, for example. You have certain circumstances, you have framework conditions, influencing factors, which tell you constraints, which tell you whether this is a good or a bad bypassing. Yes. So that is because of these costs, which means not every bypassing is a good one. So that means you have also to take care which kind of alternative route you use, and that means you have to analyze different ways of finding alternatives, and these alternatives have to be then has to be evaluated according to what you're saying, to these cost structures. Is that right?
That's absolutely correct. Of course, you definitely want to give lots of nice ideas to your client, but the objective is not to give nice ideas. The objective is to give something that you have high confidence that I can solve the problem, so avoid the infringement without deteriorating performance and without costing too much. And in that respect, you need to make sure that you generate a variety of different directions, but you need to be ruthless with your own ideas. You need to be ruthless with your own ideas so that you don't end up having a theoretical exercise with lots of nice ideas, etc. The stakes are very high there. So you need to produce a few solutions with a high confidence that they can do the job. And so to do that, you need to be very structured, systematic in this approach. And essentially, the process that we follow on that is, first of all, to look at the potentially infringing claim, represent it hierarchically, and take each small element to it as a distinct element. Then for each one of those elements, articulate and surface hidden assumptions. Because one of the biggest problems that product development teams have when they're in relation to their own designs is that they're not aware of the assumptions that they're making. I'll give you a very simple example to explain that. Let's say that you have a claim about the material composition, and it gives certain constraints with regards to percentage volume of this constituent from this to that. A hidden assumption may be that that percentage volume composition is for a homogeneous layer of the material. The moment that you articulate that assumption, that hidden assumption that the product development team themselves, the inventors themselves, take it for granted. But the moment that you articulate that assumption, it opens up a door that says, hey, what if I don't have a homogeneous layer? Okay,
Yeah,
that may open possibilities. So you do that, you break it down, you articulate the hidden assumptions, then you articulate what elements of that claim you cannot touch. They need to be there because they're directly serving the objective, or they are directly linked to a structure that you have for your product that you can definitely not change. It would be prohibitively expensive or whatever.
Yeah.
And then you identify the candidates that are up for grabs. And those candidates, so the candidates that potentially you can substitute or eliminate, then for each one of those, systematically, you try to generate a number of alternatives. And when you generate those alternatives, or actually before you generate those alternatives, first, you need to review the rest of the domain. Because the last thing that you want to do is to try and generate a number of nice ideas about how to avoid infringing this patent. And in the change, the change design, ending up infringing somebody else's patent.
Yes, got
And
you.
so, but at the same time, the review of the domain is going to act like an inspiration from you, so that you can pull ideas from other patents and work with them. And then once you have that variety of ideas, you make a first assessment. You get rid of the ones that clearly don't meet the criteria. Then on the preferred directions, you go through another process that we refer to it as conceptual expansion. So you generate lots of variants for that. You reassess them. And then once you have something that has high promise, you need to start developing it a little bit so that you have confidence that it can indeed do the job, not only of infringing, but do the job in terms of the required performance and the cost constraints, etc.
Yeah. So now, what I understand now is that that there is a huge difference whether you do that these inventing around procedure when you want to do it for your own patent, so to have a broader understanding of the alternatives which you want to forbid, for example. So then these cost constraints or whatever are simply not your problem. Yeah. On the other hand, when you want to bypass, when you want to find alternatives, and when I get your example with this homogeneous layer, maybe you can create with an alternative an inhomogeneous layer, and then you do something in addition on a higher system level to homogenize it. Yeah, for example. So then your mixture is not is not able to make a homogeneous layer, but you have a mean to make it then later on homogeneous, and that is your bypassing of, for example, that pattern. So
It could, yeah, it could be, or in that particular example, it may not be necessary to have a homogeneous layer. So if, for example, you have a layer and the composition of that layer is to achieve some surface effects, then you may achieve those surface effects, for example, with doping or whatever, so that you don't need to have a homogeneous layer. And actually, sometimes going through that process is not just a process of working around the pattern, but it may generate a new invention. And so you may also talk about inventing around a new pattern, because the solution that you come up, it could be something novel and valuable, that in itself, it may be worth protecting.
Yeah. So we have very interesting comments and questions, but they are to a certain extent too big. But I would like to focus on a different issue, which Maya Singh approached a little bit. This is, so at the moment we talk about a one-to-one issue. Okay, so I have one invention or one product, and there is one patent, and then I try to bypass it. But what happens when this is not the case? When the case is that on the other side there is really a portfolio, okay, and or what Syed said, that we have a globalization, a globalized problem, and we have lots of patents which influence us. So how can we act then?
Yeah. Well, that's a much bigger problem. So essentially, good companies know that sometimes a single patent cannot do the trick in protecting what they need to protect, and they develop a portfolio. Is like laying down a minefield. And so in that, they may do two different things. One is to protect different functions of a product, not just one. And those functions may be interrelated. So a design parameter may be impacting one or more functions. And the other thing is that they may be filing multiple applications for many variants of an implementation. So in that case, if you take each patent one by one after the other, essentially you end up in a juggling exercise. And you don't want to have that. You don't want to have a situation where you do something, a change, it kind of solves the problem of infringing patent A, but you're still infringing patent B, or that change ends up infringing patent C, and then you go back and forward. Very, very messy. So the way
you need a broader picture, right?
You need the big picture. So the way to do that is through the construction of a claims chart. But there's a special thing about constructing that claims chart. You need to take each claim, decompose it, and then restructure it on the basis of functional groups or on the basis of subsystems. And every feature in the claim or every element of the claim related to this subsystem, group them hierarchically under that subsystem, so that then when you're examining the options that you have in manipulating things, you take a subsystem and you say, okay, these features of this subsystem, this is what is being claimed. And so you have that global picture of what potentially you can do. And the first thing that you try to do is to see if it's possible to have a silver bullet. A silver bullet meaning a single change in your design to avoid infringing all of those patents. And we have developed a tool that helps us to manage that, where essentially you can just enter a change to a feature of the claim, and automatically you can see if that does the trick across all the patents or not. You can highlight the potential candidates that you can explore if they can do the trick or not. And sometimes you cannot find a single bullet. So in those cases, then you need to see whether you need to do two or more changes to your design to avoid the infringement across the range of patents of a competitor.
Okay,
and then there is another complexity, that is not just your competitor's portfolio, but you also need to make sure that in whatever change you do, you don't end up infringing somebody else's patent. So you may then need to have a parallel claim chart to confirm that. But the critical thing is having that global picture with a tool that enables you to see through that grouped set of features, and the grouping could be on the functional or subsystem basis, what potentially you can eliminate or substitute, and whether a single change can do the trick, or you need to do more than one change. And if you have more than one change, then perhaps from a design point of view, you need to explore it, perhaps using principles of axiomatic design, etc. How that comes together in a good design, where that design parameter that you are changing, how it affects one or more functions or the attributes of the product.
Yeah, I got you. I mean, that is when you say so here, when you want to do that, what you explained, you need really an understanding of the product, right? And of the usage of the product. So there comes in that you comes from a product development perspective. And you really need it's not just technologies or just avoiding infringements. It is also that that at the end of the day, a product has to come out, which is doing the job. And so so that means you come from the product, from the use case, and maybe you are able to solve the problem in a completely different way, or at least in a way which is avoiding all these infringements. That reminds me, by the way, to a discussion which we had at Thermomix, this kitchen machine, and everybody around the globe. So they had the brilliant idea. We download recipes from the cloud to the kitchen machine, and then we use that recipes on the machine. Okay. The problem was that even in that time, we had thousands of patents which explained that. Okay. So no way. And then the silver bullet was at the end that all these patents, all these download data to steer a machine have the logic that the machine is smart, so that you have lots of calculation power in the machine. It's called edge computing at the end. So you don't trust the connectivity, you trust the computer in your machine. So try to avoid data exchange and make all the calculations edge. So, and what we said is, okay, we do exactly the opposite. So we make the machine quite stupid, so to speak, so not that much calculation are there. And we trust that we will have the bandwidth to communicate with the cloud. So we make all the tricky things in the cloud and not at the machine. And
so you're not then transmitting a recipe, you're transmitting operational parameters, for example.
Exactly. So that was the solution. That was this silver bullet in thinking in a completely different way, because otherwise you have this extremely crowded situation. So one thing what is discussed in the chat right now is that FTO can be just a temporary issue, because we have this very nice US way of filing divisional applications, and that can be an issue, obviously. But I have one question in mind which also triggers me, because obviously, I mean, at the end, this is a, let's say, project. Okay, so I have a problem, I see a potential infringement, and I want to know. So it's a bit. It reminds me to this valuation issue. So that yes, I give you the job to write me a valuation report, but first of all, I want to know what comes out. Okay, before I spend the money that you make the valuation. So this is this egg and hen problem. And to a certain extent, here we run in the same difficulty. So I would like to know quite early how good are the chances to come up with a reasonable solution for my problem, for my infringement problem. what can we do with this forecasting of a potential success here?
Yeah. Okay. Absolutely critical. Let me make a very quick point on the comment before from the audience in terms of the FTO being a temporary issue. It's a snapshot in time. But if you have a good claims chart covering that domain, then you have a structure that the engineers can relate to because it's by subsystem or by function. And then each new relevant pattern that comes up is very quick and easy to add it to that thing and reassess it and see the implications. So that is a quick answer to that. So going to the main question of can you have confidence essentially when you say, okay, can I actually work around this claim? And my answer to that, I can give it in the form of a question saying, well, how do you climb a fence? And you climb a fence by taking advantage of its structure. So the first thing that you do is that you look at the structure of that claim in terms of how many handles and what type of handles it offers you to try and explore alternatives.
Yeah.
And as you have a number of handles there, you place yourself not as a pattern analyst, but as a product development engineer, and then you say, okay, let's start to make some thought experiments about possible alternatives for this, that, and the other. And very early on, you start to create a feeling of the level of difficulty of generating possible alternatives in the face of the constraints that you have. So a key thing is first to articulate those constraints, and then go and explore what needs to be done. Because you don't want to promise that you can go around, generate lots of nice ideas, but they are not truly applicable because they would not meet those constraints. But the simple answer to that would be that in most cases, you can basically give an assessment and say, yeah, good confidence, we can go around it. That's what I estimate that it would take as an effort. It's a similar way to preparing a proposal to a client when you are having a task of developing a new technology and you're not operating on the base of time and materials. You give a fixed fee. Again, you need to make some assumptions.
Got you. So this is a combination of experience on the one hand, and on the other hand, this is physical principles, mechanical principles.
Yeah.
And so when you look at it and the breadth of the claims compared to the question what the product at the end should be, and that gives you a good understanding whether this is possible or not. Got you.
Yeah, and what the client is prepared to change, what commitments are there. So if, for example, already molds are in place and the cost of changing the tooling is huge, then you need to have early on a feeling of what is possible to change it and what you cannot touch.
And that fits very good with my own things that he said, all what we discuss here is very depending on the risk appetite of the company or of the institution. And I mean, to say that is you come into play when things are difficult, when the stakes are high, and especially then you need somebody who opens doors for getting out here, and that is I would say the solution, a part of the solution might lie here in changing things. So, Nicos, thank you very much for that, and thank you to the audience for these very tricky questions. Nicos, be so nice and go to LinkedIn, to the chat, and discuss with the guys, because there are tricky questions which are absolutely relevant and interesting, and we should be there in the after show party on LinkedIn to go deeper on that topic. So thank you very much.
Excellent.
And
thank you.
to all the others, enjoy your day. Bye bye. Till the next.
Bye bye.